For my standard 2.1, I chose to do question 2.8 out of the book, and it asks us to find the probabilities of the measurements shown below in figure 214. Here I have drawn figure 214. The first Stern-Gerlach analyzer is aligned along the direction n hat, defined by the angles theta equals pi over 4 and phi equals 5 pi over 3. So from this we can get our equation of state, which is right here. The measurement by the analyzer prepares the system in the spin up state along the n hat direction. This state is the input state to the second Stern-Gerlach analyzer. Adding our angles to our system, it becomes this. So you see we had theta right here, so we plugged in theta equals pi over 4. So pi over 4 divided by 2 is pi over 8. So we have pi over 8, and then our phi angle was 5 pi over 3. So that's right there. Solving for cosine and sine of pi over 8, we are left with this. Our second analyzer is aligned along the y-axis. Recalling that matrix representation for our spin up and spin down kets in the y direction are these in the matrix representation. To solve for probabilities in the y direction, we can use these equations. Now it follows that the probability, using those equations on the last page, probability in the spin up y direction is this. So we plugged in our bra for the spin up in the y direction. And you can see it's a column vector now, since we took the adjoint of this, so we can turn our, because this is a ket in the y direction, we need a bra, so I took the adjoint of this, and that leaves us with a column vector. And it also switches the signs of our imaginary parts, so that's why it's a negative I now. And we're taking the inner product of our column vector of our system, or the matrix representation of our system, which is a column vector. So going through it, this is after putting the square through and using Euler's formula. We can rewrite this as this. So Euler's formula is applied right here, which allows us to write this as 2 cosine of 5 pi over 3, which is equal to 1. So after plugging this in the calculator, we get our probability to spin y is 0.1767. Now for the spin down in the y direction, we follow the same steps, and using matrix algebra and Euler's formula again, we are left with this, and our probability to spin y is 0.5303. And this is my standard 2.1.